Hey there, science enthusiasts! Today we're diving into a question that's on the minds of many. What if a solar storm hit Earth in 2025? Are we ready for it, Day? Let's break it down. Solar storms, or coronal mass ejections, are massive bursts of solar wind and magnetic fields rising above the solar corona, or being released into space. When these ejections are aimed at Earth, they can cause geomagnetic storms, which can potentially wreak havoc on our planet's technology. So, what kind of impact are we talking about here? First up, power grids. A strong solar storm can induce electric currents in power lines, leading to transformers overheating and, in the worst-case scenario, widespread power outages. Remember the Quebec blackout of 1989? That was caused by a solar storm and left millions without power for 12 hours. Now imagine that on a global scale. Next, let's talk about communications. Our modern world relies heavily on satellites for everything from GPS navigation to internet services. A solar storm could disrupt satellite signals, causing communication blackouts. Air travel could also be affected, as pilots rely on GPS for navigation. In extreme cases, flights might be grounded altogether. Now, you might be wondering, how likely is it that we'll face a major solar storm soon? According to NASA, the Sun goes through an 11-year cycle of solar activity, known as the solar cycle. We're currently in solar cycle 25, which is expected to peak around 2025. During this peak, the chances of a significant solar storm increase. But here's the good news. Scientists are constantly monitoring the Sun's activity. Organizations like NASA and NOAA have satellites and telescopes dedicated to observing the Sun and providing early warnings of potential solar storms. This gives us some time to prepare and mitigate the effects. What can you do to stay safe? Simple steps like having an emergency kit, keeping backup power sources, and staying informed through reliable news sources can make a big difference. And of course, listen to the advice of experts. So, are we ready for a 2025 solar storm? While there's no guarantee we can avoid all disruptions, our growing understanding of space weather and improved technology put us in a better position than ever to handle such an event. Stay curious, stay prepared, and keep looking up. Thanks for watching. Don't forget to like, subscribe, and hit that notification bell for more fascinating science content. See you next time. Welcome back, science enthusiasts. Now that we understand the potential impact of a solar storm hitting Earth in 2025, let's take a journey through history and explore some of the most significant solar storms that have impacted our planet. These events have not only left their mark but have also shaped our understanding of space weather. First up, the Carrington event of 1859. Named after British astronomer Richard Carrington, this solar storm is the most powerful geomagnetic storm on record. When the storm hit Earth, telegraph systems across Europe and North America failed, and auroras were visible as far south as the Caribbean. Telegraph operators even reported sparks flying from their equipment. This monumental event was a wake-up call to the potential power of solar storms. Fast forward to March 1989 when another significant solar storm occurred. This storm caused the infamous Quebec blackout, leaving millions without power for 12 hours. The event highlighted the vulnerability of modern infrastructure to solar activity and spurred efforts to improve the resilience of power grids. In more recent history, the Halloween storms of 2003 offer another example. These storms disrupted satellite communications, GPS signals, and even caused some airline flights to be rerouted. The event emphasized the importance of monitoring space weather and the need for improved forecasting capabilities. These historical solar storms teach us valuable lessons. They remind us of the immense power of our sun and the need to be prepared for the potential impacts of space weather. Each event has driven advancements in our technology and our understanding of the sun's behavior. As we look to the future, it's clear that our preparedness for solar storms has come a long way. But the lessons of the past remind us that vigilance and continuous improvement are key. By studying these historical events, we can better anticipate and mitigate the effects of future solar storms. Thanks for joining us on this historical journey. Don't forget to like, subscribe, and hit that notification bell for more fascinating science content. See you next time. Welcome back, science enthusiasts. In this chapter, we'll delve deeper into the specific ways solar storms can affect our technology. From power grids to communication systems, we'll explore the vulnerabilities and the measures we can take to protect our infrastructure. Let's start with power grids. Solar storms can induce electric currents in power lines, which can overload transformers and other critical components. This can lead to widespread blackouts, as we saw in the Quebec blackout of 1989. To mitigate this risk, power companies are investing in more robust grid designs and implementing real-time monitoring systems to detect and react to geomagnetic disturbances. Next, let's talk about communication systems. Solar storms can disrupt radio signals, interfere with satellite communications, and even degrade GPS accuracy. This can have serious implications for aviation, maritime navigation, and even everyday activities like using your smartphone for directions. To combat these issues, scientists are developing more advanced forecasting models and hardening satellite technology to withstand the effects of solar storms. Another critical area is the internet. Undersea cables that form the backbone of global internet connectivity are also at risk. Solar storms can cause voltage fluctuations that could damage the repeaters along these cables, potentially leading to significant disruptions in global communications. Researchers are exploring ways to make these systems more resilient, including better shielding and alternative routing strategies. Finally, let's consider the impact on space missions. Solar storms can pose a significant threat to astronauts and spacecraft. High-energy particles from the sun can damage onboard electronics and increase radiation exposure for astronauts. To address these challenges, space agencies are developing better shielding materials and more accurate space weather forecasting tools to protect our space explorers. It's clear that solar storms present a complex challenge for our modern technology. But with ongoing research and advancements in engineering, we are better equipped to face these cosmic threats. By understanding the vulnerabilities and implementing protective measures, we can ensure the resilience of our critical infrastructure. Thanks for joining us on this deep dive into the technological impacts of solar storms. Don't forget to like, subscribe, and hit that notification bell for more fascinating science content. See you next time. Welcome back, science enthusiasts. In this chapter, we'll look at the tools and techniques used by organizations like NASA and NOAA to monitor the sun's activity and provide early warnings of potential solar storms. First, let's talk about solar observatories. These specialized telescopes are designed to observe the sun in various wavelengths, from visible light to ultraviolet and X-rays. By analyzing these observations, scientists can detect sunspots, solar flares, and other phenomena that indicate increased solar activity. One of the most important tools in this arsenal is the Solar and Heliospheric Observatory, or SOHO, a joint mission by NASA and the European Space Agency. Launched in 1995, SOHO has been providing continuous monitoring of the sun, offering invaluable data to help predict solar storms. Another key player is the Solar Dynamics Observatory, or SDO. This spacecraft captures high-resolution images of the sun, allowing scientists to study its magnetic field and understand the processes that lead to solar eruptions. By combining data from SOHO, SDO, and other observatories, researchers can create detailed models of the sun's behavior. But observation is just the first step. To provide accurate forecasts, scientists use advanced computer models to simulate the sun's activity and predict the likelihood of solar storms. These models take into account various factors such as the sun's magnetic field, the speed and direction of solar wind, and the position of sunspots. One of the most widely used models is the Wang-Scheele-Arge (WSA) model, which combines solar observations with mathematical algorithms to predict the arrival of solar wind at Earth. This model has been instrumental in improving the accuracy of space weather forecasts. In addition to ground-based observations and computer models, scientists also rely on a network of satellites to monitor the sun and its effects on Earth's space environment. The Advanced Composition Explorer, AC, and the Deep Space Climate Observatory, DSCO-VR, are two such satellites that provide real-time data on solar wind and geomagnetic activity. By integrating data from these various sources, organizations like NASA and NOAA can issue timely warnings of potential solar storms. These alerts are crucial for protecting our technology and infrastructure as they allow power companies, satellite operators, and other stakeholders to take preventive measures. It's a complex and challenging task, but thanks to the dedication and ingenuity of scientists and engineers, we are better prepared to face the threats posed by solar storms. By continuing to advance our understanding of the sun and improve our forecasting capabilities, we can mitigate the impact of these cosmic events on our modern world. Thank you for joining us on this journey into the science of solar storm prediction. Don't forget to like, subscribe, and hit that notification bell for more fascinating science.